can go to the shops, you can buy a mobile phone, you can show your family, and you can say, look, I did this, this is graphics been rendered by an imagination processor, and you can really see it. You think back to the early days of computer gaming and the quality of the graphics to the realism that you see today. We're constantly adding more and more realistic features in terms of shadows, and now we're adding ray tracing so that you get these ultra realistic images that almost look like real life. So that's really cool being part of that. Everywhere that you see a screen, there's a good chance that there's an imagination GPU powering the graphics that sit behind that.
So the IP is sold into various spaces: automotive, mobile phones, tablets, PCs, data centers, that sort of thing. And that's offered to our customers in the form of RTL. And my team's job is to help our customers turn that RTL into working silicon. So the imagination architectures provide leading edge PPA. But what they like about working, I like to think, with imagination is the ease of integration of that IP. So we have an integration flow which we've developed together with Cadence over a number of years, which enables them to have a great deal of confidence that they're going to be able to meet the PPA goals that they expect, and also meet those goals within a reasonable time frame so they hit their tape out targets.
At the front end, we work very closely with Cadence on verification. We use their Excellium simulator products, and we use an awful lot of their Palladium emulator, which accelerates our verification process. So these are huge GPUs that require frames of real graphics data to be run on them, and using Cadence emulators allows us to accelerate that and run real use cases on effectively a model of the system, and then all the way through the physical design. So from synthesis and place and route all the way to physical sign-off, ensuring that we can then hit the physical characteristics we need: the power, the performance, the area.
We make full use of Genus for synthesis, Innovus for layout, Conformal LEC for verification, plus also Tempus and Quantus, so that we can do sign-off quality, timing, analysis of our designs. We require the ability to do a full hierarchical flow because some of our designs are very large, because our RTL is configured in such a way that even for the most complex of the designs, we've partitioned things in such a way that we can reuse as much as possible and do as much parallelism in the implementation flow as possible.
It's not just imagination and Cadence separately, but we turn up together and we can provide things like reference methodologies, so a kind of recipe of how to build our IP into silicon. And we can help them get started very, very quickly and make sure that they hit the power and performance targets. So there's a sort of partnership element where we work together, turn up our customers together and support them as they go through that journey to building silicon.